An earthquake is a sudden shaking or vibration of the Earth's surface, caused by the release of energy in the Earth's crust. The Earth's crust is made up of large tectonic plates that float on top of the molten mantle below. These plates are in constant motion, driven by the movement of hot molten rock in the Earth's interior. When two tectonic plates move against each other, the energy that has built up along the boundary is suddenly released, creating seismic waves that propagate through the Earth's crust. These waves can be felt at the surface as shaking, and can cause damage to buildings, roads, and other infrastructure. Earthquakes can also be caused by other factors, such as volcanic activity, landslides, or man-made activities such as underground nuclear testing or the construction of large reservoirs. The intensity of an earthquake is measured using the Richter scale, which is a logarithmic scale that ranges from 0 to 10. Each increase in one unit of the scale corresponds to a tenfold increase in the amplitude of the seismic waves. An earthquake with a magnitude of 2.5 or less is usually not felt, while those with a magnitude of 7 or more can cause widespread damage and loss of life. Scientists study earthquakes to better understand the structure of the Earth's interior, the motion of tectonic plates, and the potential for future seismic activity. They use a range of tools and techniques, such as seismometers, GPS, and satellite imagery, to monitor and predict earthquakes, and to help prepare communities for potential disasters. Earthquakes in Syria and Turkey are common, but the magnitude 7.8 that shook the region on the 6th of February at 4:17 am local time is clearly impressive. To find earthquakes this strong on this particular fault, we would have to go back to the year 1114. 10 minutes after the strongest earthquake, an aftershock of magnitude 6.7 struck near the epicenter. Aftershocks are earthquakes that occur after every major earthquake, and their statistical behavior is well known. At the time of writing, others continue to affect an area stretching over 350 kilometers from eastern Turkey to the Syrian border. More surprisingly and dramatically, a second earthquake of magnitude 7.5 struck at 1:24 p.m. local time, further north. This earthquake was not an aftershock, according to the first data processed live by the major international seismological agencies. It would have occurred on an east-west fault crossing cutting the main rupture trace. Earthquakes may trigger other earthquakes. An earthquake happens when a fault, a fracture in the first kilometers of the Earth's crust, slips rapidly, within seconds, abruptly releasing the energy that has been growing over tens to hundreds of years by the slow motion of tectonic plates. When this happens, the released energy leads to shaking of the ground, the earthquake. Some earthquakes are linked to each other. When the fault breaks, earthquakes release part of the energy and reorganize part of it in the Earth's crust, which can trigger new earthquakes. For instance, one can consider the series of earthquakes of magnitude greater than 7 that have cascaded from east to west for about 800 kilometers over the course of the 20th century along the North Anatolian Fault. Each earthquake brought the nearby fault segment of the North Anatolian Fault closer to a rupture. The notable point is that the entire length of the North Anatolian Fault ruptured between 1939 and 1999. The last unbroken segment runs across the Sea of Marmara, very close to Istanbul, between the epicenters of the 1999 Izmit and 1912 Ganongs earthquakes. Mechanism of the earthquake in India. India is situated on a tectonic plate that holds the land mass of the Indian subcontinent and the Indian Ocean. This place is ramming the Eurasian plate, which is moving south. These two plates have been colliding for a few million years. Their collision raised the tallest mountain structure on the Earth, the Himalayas. The Indic plate is heavier and hence is sinking below the Eurasian plate. The collision is still happening and the Indic plate is still submerging beneath the Himalayas at the rate of 5 to 6 centimeters every year. True, India is losing its 5 to 6 centimeters of land to its northern neighbor every year. The Indic plate is huge. To move such a big body, immense energy is needed. This energy is being generated beneath the crust, topmost 30 to 50 kilometers surface of the Earth, in the molten mantle. It acts like a furnace. Energy moves upward and jets out in different directions. This illustration explains the mechanism. The same thing is happening with the Indian landmass. This is causing strain on the rest of the shield. The shield has too many faults or linear zones of weaknesses. These faults crack or shake when there is excessive energy flow or strain.